Hello, calculus students. Today we're going to go ahead and go over some common questions that I received from the applications problems that you received over the week with free response. So this first video is going to be about derivative applications and rates. The questions that I was asked to complete are 2019 free response question number 1, B and D, and then finally 2014 number 1A. And looking through these problems, it seems like the biggest issue that we are having is knowing what procedure to use when. So before we go all crazy, I want you to kind of remember some of the key things. If I'm asked for an average value of something, well, think about calculating a mean. You're adding up everything and dividing by the total. So if in calculus I'm asked to find the average value of something, I need to add them all up using an integral and then divide by the total number. However, if I'm asked for an average rate of change, that's just a fancy slope problem. So let's go ahead and use that in this piece of information. So the classic fish problem, I think we've seen this at least 2 times this year. We have fish entering a lake at the rate of E of t, and then the fish are leaving the lake at this rate. Both E and L are measured in fish per hour, and T is measured in hours since midnight. All right, so for first part, it says, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5? The average number of fish that are leaving over the 5-hour period. All right, so here's the way that I would do this. The average number of fish that are leaving per hour. Well, let's go ahead and add up all of those rates and then divide by the total. So this is why, not this problem. This is why it came up with this. We are adding up all of the fish that are leaving per hour and then finally dividing by 5 hours. So the average number of fish that leave the lake per hour from midnight to 5 a.m. is 6.059 fish per hour. We added up how many are leaving, divided by how many hours, and that is what we are getting there. All right, next problem. Somebody asked a very, very good question on this one. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. All right, well, I want to go ahead and show you a graph here. E is the rate at which fish are entering, and L is the rate at which fish are leaving. So right now, there are more fish entering than there are leaving. Here, there's more fish entering than leaving. Right here is kind of your break-even point. And then finally, from this point on, there are more fish that are leaving than are entering. Now, this question is specifically asking us, is the rate of change in the number of fish increasing or decreasing? Now, I want to warn you about something. If we strictly look at E at 5 and L at 5, well, of course, there are more fish entering than are leaving. But we're not asked, are there more fish entering or leaving? We're asked, how is this rate changing? Well, yeah, there's more here and more here, but let's take a look here in just a moment. E at 5.1 versus L at 5.1. Ooh, all right, well, this is going down and this is going up. So this gap is closing. This gap is closing, and the way that we would calculate that is actually not by the function values, but by looking at the derivatives. So the derivative of E at 5 is decreasing. The rate at which fish are entering is decreasing. The rate at which fish are leaving is increasing. So that change, if we look at the problem, because the rate at which they're entering minus the rate at which they're leaving is negative, you could have just directly compared those two and said, hey, this is smaller than this. Because this is negative, the rate is decreasing at time t equals 0. The rate of change is decreasing. So yes, there are more fish entering than leaving at this time, but notice that gap is narrowing. That rate of change is decreasing. All right, we had one other question about derivatives, and that is the very first one. Ooh, I like it. All right, so grass clippings are placed in a bin where they decompose. The amount of grass clippings in the bin is modeled by A of t. So A is our amount in the bin, where A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval, average rate of change. So as soon as I'm seeing average rate of change, I want to know what is my overall change of this between 0 and 30. Well, average rate of change here, that would look like this. Average rate of change, how many grass clippings are there at 30 minus how many are there at 0 divided by 30 minus 0. So this one is decreasing in pounds per day. Now, what would this question look like if I were asked, if I needed to do an integral here? Well, I'm going to go ahead and write a second question, a Walton A question. All right, that would require the other one. Find the average amount of grass clippings over the interval 0, I gotta type this in, 0 less than equal to t is less than or equal to 30. All right, how is this question changed? We're not asked about the average rate of change. We're not asked how is this changing from 30 to 0. This is saying, hey, what is the average amount of grass clippings over this interval? Well, you would add up all of the grass clippings and then finally divide by 30. So this one would require your integral. All right, so I hope that helps clarify things. Take a moment to see, are we taking an average rate of change or are we figuring out an average value of a function? Average rate of change. Average rate of change is essentially a slope problem. If we are asked for an average value of a function, that is where we are adding and dividing by total. And that is the adding is our integral. All right, hope that helps you. This is all for derivatives. Please let me know if you have any more questions.